Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. To increase the optical purity, enantiomeric excess, of a chiral compound, a chemist performs a resolution. Resolution of a racemic or enantiomerically impure acid requires converting it into diastereomeric salts using an optically pure, enantiopure, chiral base or, alternatively, reacting a chiral acid with an enantiopure chiral amine base. However, when the target compound, D, is itself a carboxylic acid, cyclohexanicarboxylic acid, resolution is typically achieved by forming diastereomeric salts with an optically pure chiral base. But another classical method is to use an optically pure chiral acid to form diastereomeric salts with a chiral amine, or, when dealing with a chiral acid to be resolved, to use an optically pure chiral acid as a resolving agent in conjunction with a base, forming diastereomeric salts that can be separated. Step 1. Identify the target. Compound, D, is R, cyclohexanicarboxylic acid, a chiral carboxylic acid whose optical purity needs to be increased, i.e., the sample contains some of the S enantiomer and needs to be enriched in the R form. Step 2. Principle of resolution. To resolve, separate, enantiomers of a carboxylic acid. One classic method is to react the racemic impure acid with an optically pure chiral base, like brucine, strychnine, or a chiral amine, to form diastereomeric salts, which have different physical properties and can be separated by crystallization. Alternatively, a chiral diacid can serve as a resolving agent for chiral amines. The key requirement for a resolving agent for an acid is that it be a chiral, optically pure compound, often a chiral amine for an acid substrate. Step 3. Evaluate the options. A. 4-hydroxybenzoic acid. This compound has no stereocenters, it is a chiral. It cannot form diastereomeric salts and is useless for resolution. B. 2R, 3R, 2,3-diphenylsuccinic acid, or one specific enantiomer of diphenylsuccinic acid. This is a chiral diacid with 2 stereocenters. Being enantiomerically pure and chiral, it can be used as a resolving agent. In practice, optically pure chiral acids are used to resolve chiral amines, but a chiral acid can also serve in resolution schemes involving conversion to esters or other derivatives with chiral alcohols, or as part of a salt with a chiral base derived from the target. More directly, an enantiomerically pure chiral acid like R,diphenylsuccinic acid is a known classical resolving agent. It is chiral and optically pure, making it suitable to form diastereomeric derivatives, example, diastereomeric salts if the cyclohexanicarboxylic acid is first converted to its amine, or diastereomeric esters, that allow separation and thus increase optical purity. C. The mesoform of 2,3-diphenylsuccinic acid. The meso compound has an internal plane of symmetry and is achiral overall, despite having stereocenters. It cannot distinguish between enantiomers and is useless for resolution. D. This is the compound to be purified, not a resolving agent. Step 4. Conclusion. Only option B, the enantiomerically pure, non-meso, chiral diacid, is capable of acting as a resolving agent to increase the optical purity of the D sample. Options A and C are achiral, or effectively achiral, and cannot differentiate enantiomers. Option C is the meso compound and is achiral. Therefore, the correct answer is B. Therefore, the correct answer is option B.